Hello students, this is the third lecture on polymer. I am Dr. Abhijit Shaha. I am taking BTech chemistry course and this polymer is a part of your BTech chemistry syllabus. In this lecture, I will discuss on conductive polymer. You will understand the reason of conductivity in polymer, will understand the mechanism of conductivity in polymer from this lecture. So first we'll discuss what is conductive polymer. So we know that polymer materials it is prepared from some monomer molecule. Now for example, if we take acetylene molecule and prepare one polymer, it will form polyacetylene. Now we can see that in this polyacetylene there is a double bond, single bond, double bond, like this type of structure means there is a possibility of conjugation of electron. This polyacetylene can be two type, one is cis and trans. Okay. In both cases, there is a possibility of pi conjugation. So pi bond can move from one side to another side. So this is the reason of conductivity in the polymer. So if we take instead of polyacetylene, if we take polyethylene, then polyethylene will not be conductive because in polyethylene there is no conjugated pi system. Since in polyacetylene there is a conjugated pi system, this polyacetylene is a conductive polymer. There is another example of conductive polymer is polyaniline. Okay, this is aniline molecule. If we react aniline molecule with HCl, we will get anilinium chloride or aniline hydrochloride. Now, if we react aniline hydrochloride with some oxidizing molecule like ammonium NH4 whole 2 H2O8, we'll get this type of conductive polymer. The reason of conduction is again there is a pi conjugation. See, this is pi bond can be conjugated, right? Again, this pi bond can conjugate it like that. Electron can move from one side to another side of the polymer chain. Because of that, we can get this conductive polymer. Okay. However, only these molecules is not too much conductive. So if we see that conductivity of this polymer molecule, it will be very low. Now we can increase this conductivity. We can increase the conductivity of trans polyacetylene sample after adding some external molecule which is called doping or dopant. If we react polyacetylene with some molecule like chlorine, bromine, iodine, we can see that polyacetylene becomes 10 to the power 9 times more conductive. Again, if we react the molecule with some with arsenic pentafluoride, again we can see that conductivity is increased. Okay, reducing agent like sodium, metallic sodium has also successfully used to increase the conductivity. So this chemical, which is called dopant, is able to transform polyacetylene from insulator, semiconductor to conductor. So actually polyacetylene is a conductive polymer. It has ability to conduct, it has ability to uh, transfer electron from one side to another side. However, this conjugated double bond, however, uh, this ability of conduction is not so high. If we want to increase this conduction, we have to use some external molecule which is called dopant. Now dopant can be different type: metallic sodium, arsenic pentafluoride, chlorine, bromine, iodine. These are called the dopant. So the main structural features of conductive polymer is the presence of conjugated double bond. If conjugated double bond is present, then only polymer can be conductive. If conjugated double bond is not present, then polymer cannot be conductive. While this conjugated double bond is present, this double bond is localized. Since it is localized, it is not able to. It is localized. This localized double bond is prevent the electron conduction. Now, if we use dopant, what is happening? If we use dopant, it will it will increase it will increase the electron density at some site, or it will create some electron deficiency at some site. When a deficiency of electron or holes is created, electron flow to fill this hole, with the newly created hole causing other electron to flow to fill the hole, allowing the charge to migrate from one side to another side of the polyacetylene chain. Okay, so the main objective of use of dopant is to enhance the delocalization, to facilitate the delocalization of the electron and making the polymer much more conductive. So what is the summary from this part? Summary is conductive polymer. The polymer molecule can be conductive if there is a conjugated double bond. First thing. Second thing, this conjugated double bond, presence of this conjugated double is not enough for sufficient conductivity. It has conductivity, but it's not sufficient. We can enhance this conductivity by use of dopant. Now, dopant is a molecule which is able to enhance the electron density in the molecule, or it is able to uh, enhance the electron deficiency, or making create the hole in the conjugated polymer molecule. When this extra electron, or the extra positive charge means hole is created, then electron is moving from one side to another side. That is the role of dopant, to enhance the delocalization of electron and making the polymer much more conductive. Now this conductive polymer can be two types. One is intrinsically conductive polymer, another one extrinsically conductive polymer. Intrinsically conductive polymer means the polymer molecule which is itself conductive, where region of conduction is the conjugated double bond. Extrinsically conductive polymer is the polymer molecule which is mixed or blended with some other blended molecule. It's mixed with some other molecule, where the other molecule or blended material is responsible for conduction. Okay, so difference is intrinsically conductive polymer, the polymer itself is conductive. Polymer itself is conductive because of presence of conjugated double bond. Extrinsically conductive polymer means the polymer is mixed with some conductive material, which is called blended material. Polymer is mixed with some conductive material. Because of that, total polymer material is conductive. So extrinsically conductive polymer can be two types. One is polymer blended with conductive element, polymer blended with conductive polymer. Okay, so these are the two types of extrinsically conductive polymer. Intrinsically conductive polymer is also two types. One is conjugated conductive polymer, another one dope conductive polymer. Means intrinsically conductive polymer two type. One is polymer itself is conductive, where conjugate double bond is present. Another one, conjugate double bond is present, and along with there is some dopant is also present. Means when dopant is present, polymer become much more conductive. Without dopant also it is conductive, but when dopant is present, it is much more conductive. So these are the both type of intrinsically conductive polymer. Okay. Okay. Now, conduction in conductive polymer is the reason is that is conjugated double bond, right? We have understood. Now we'll understand in details, right, what is the reason of conduction. So if we have conjugated double bond, like conjugated pi system, so electrons is localized, right? Now if we now electron is localized. Now if we see the molecular orbital of this conjugated double bond system, molecular orbital, it will be, we can have one HOMO, another is LUMO. If we see this diagram, okay, for ethylene molecule, where two electrons are present, one HOMO, one LUMO. Butadiene molecule, this is HOMO, LUMO. Octatetraene molecule, there is HOMO and LUMO. But what is the difference? We can see the gap between HOMO and LUMO is decreases. So homolumo gap decreases if we increase the number of number of conjugated double bond. So in polyacetylene there will be one homo, there will be one lumo. Now this all there is one part which is part of orbital which is called valence bond, another part which is unoccupied electrons which is called conduction band. Okay, so when polyacetylene is formed, so there is actually two band. One is conduction band which is unoccupied, which is vacant. Another one is valence band which is occupied by electron. Right. Now this homolumo gap, pi homolumo gap is important. So if the gap between valence band and conduction band, valence band means where electrons are present, conduction band means electrons are absent. So when this gap between valence band conduction band is very high, it is called insulator. When there is no gap, it is called conductor. When the gap is in between, it is called semiconductor. Okay. Now in polyacetylene, polyaniline, all are actually mainly semiconductor. But if we use some dopant, then dopant will come here. So band due to dopant. Then valence band and conduction band gap actually decrease because electron move from valence band to dopant and dopant to conduction band. Like that it is going on. So the electron has to travel less energy gap. So because of that conduction increases. Right. So what are the requirement for conductive polymer? Requirement is there are three important requirements. First, polymer should have linear backbone. Okay, first important. If it is not linear, then electron cannot move easily. Second thing is that it should have extended conjugation. Conjugated pi bond must be present. And third one is optional. If it is present, there will be much more conduction. If it is not present, then also it is possible to conduction. So third one is optional. It is called a charge carrier, either positive holes or electron should be introduced by appropriate dopant to make conductive polymer. Okay. Now what are the dopants? So there is two types, p doping and n doping. P doping means positive, creating positive plus or creating holes in the polymer. N dopant means creating negative. Negative means extra electron in the polymer. So if we react polymer with some Lewis acid to make p dopant, in p dopant means we have to create hole or we have to create some electron deficiency in the polymer. So means we have to add some plus charge in the polymer. So how it is possible? So if we react polymer with some Lewis acid means electron deficient. So if we react polymer with some Lewis acid, so electron will move from polymer to Lewis acid, right? So in that way, there will be a hole will be created in the polymer, right? Right? For example, if we react polymer like polyacetylene with iodine, we will get a hole in polyacetylene and we will get I3 minus. Similarly, if we react polyacetylene with FeCl3, we will get some electrons will move from polyacetylene to FeCl3 and it will make FeCl4 minus and polyacetylene plus, right? So in that way, one hole will be created in the polymer. Since hole is created, positive charge is created, it is called p doping. So for p doping, we can use Lewis acid. In this Lewis acid, creating positive side in the polymer. Because of that, it is called p doping. N doping N doping means negative charge, creating negative charge in the polymer. So if we react polymer with Lewis base means extra electron is present. This extra electron will be added on the polymer. For example, if we take polyacetylene and react with sodium naphthalide there is a negative charge on carbon. Now if this electron is given, if the electron is moved to polymer, then we will get an extra negative charge on this polyacetylene polymer, right? If we get this extra negative charge is then this negative charge can force the electrons to move, right? So this is called n doping. Since we are getting extra negative charge, negative n, so it is called n doping. So to make conductive polymer, if we want to use n doping technique, we have to use some Lewis base. So Lewis base, for example, sodium naphthalide. Now we have to discuss the mechanism. So already I told. So for the P doping, we have to use Lewis acid, for example, FeCl3 or iodine CCl4, right? Now, what is the mechanism? So you can see this is the polyacetylene molecule. Now there is everywhere there is a double bond. So this double bond is represented by a this two electron, means every double bond there will be two electron. So these are the two electron representing the double bond. Now if we use if is Lewis acid, like iodine or CCl4. So Lewis acid means has electron deficiency. So one electron from here it will come to the Lewis acid, right? If it is one electron is coming, so we will get one extra positive charge, right? So we will get uh, this cation positive charge on this polymer chain, right? So cation radical. Okay. Now if we use so there is a much more this Lewis acid molecule. So the second electron is moved. This second electron is moved. We will get again extra positive charge here. Now this radical and this radical combine and forming this double bond. Now what is happening? Now to dication is formed, right? When this dication is formed, now electron on this double bond can move this on this side since positive charge is present. Similarly, electron on this double bond can move to this side because of positive charge is present. In that way, what is double bond moving, right? And positive charge is also moving in the opposite side. So in that way, positive side is moving from one side to another side of the polymer, and because of that, we will get the conduction. We will get the delocalization of the electron and making the polymer much more conductive. Similarly, in case of n-doping, we have to create negative charge. We have to use Lewis base, for example, sodium naphthalite. Now, what is the mechanism? Mechanism is very simple. Again, polyacetylene molecule. There is a double bond represented by two electrons. Now, when we are using sodium naphthalite, so extra electron from sodium naphthalite will go to the polymer. So, if extra electron is going, so what will happen? There is a two electron. So this is one radical, there will be another radical, extra electron is coming, so two electron means one extra negative charge, right? Now if we use another sodium naphthalide molecule, again extra negative charge will come here, we'll get another negative charge here, right? Now this electron and this extra electron will form this double bond. Now there is extra negative charge, there is extra negative charge. Now this extra negative charge can move, right? If extra negative charge is moved, this double bond electron will come here and form a negative charge here. Similarly, if extra negative charge move, this double bond electron come here, will get extra negative charge here. So in that way, again, this negative charge is moving from one side to another side of the polymer chain and making this polymer much more conductive. So this is the mechanism of conduction. So what we have understood? We have understood that in conductive polymer, there should be conjugated double bond. If conjugated double bond is present, polymer will be conductive. So this type of conductive polymer is called intrinsically conductive polymer. Now to increase the conductivity, we can use some dopant. We can use some P dopant, example FeCl3, iodine, CCl4. We can also use N dopant, negative charge, like sodium naphthalide. So if we use dopant, we are creating extra positive charge or hole or extra negative charge in the polymer. So this extra positive and or extra negative charge enhances the electron or forces the electron conductivity from one part to another part of the polymer chain. Okay, there is another type of a conductive polymer which is called extrinsically conductive polymer. In extrinsically conductive polymer, the polymer backbone is not conductive. But the blended materials in extrinsically conductive polymer, we mix polymer molecule with some externally conductive material. Now this externally conductive material can be a polymer molecule or it can be other molecule. So when this externally conductive material gets mixed with the polymer, it also forming conductive polymer. But this is called extrinsically conductive polymer. Okay, so that's all about conductive polymer. Remember that from here, uh, in exam purpose, this conductive polymer is very important. You have to know about the two example of conductive polymer, polyacetylene and polyaniline, their preparation, their uses, and also this mechanism. conductive polymer is also important for your exam. So I think you have understood what is conductive polymer, and with this I'll stop this lecture here, and thank you for listening.